With 100,000 numbers, you get almost 5 billion pairs. If you actually compute and sort every GCD, you are dead on time in memory. Here's the trick. We never build that list at all. We count how many pairs land on each GCD value. This exact shape. Pre-compute a distribution once, then answer a flood of queries fast, is how databases and analytics dashboards serve percentiles. Companies like Google and Meta love it because it separates the slow prep from the instant lookup. Learn this pattern once, and you reuse it forever. Take nums equals 2, 3, 4. The three pairs give GCDs 1, 2, and 1. Sort them into 1, 1, 2, and a query just asks for the value of some index. So query 0 returns 1, query 2 returns 2. 3 simple ideas. A frequency array is just tally marks, how many times each number appears. A sieve means we walk through multiples of each value, like counting every second, third, fourth box. And a prefix-sum is a running total, so we can jump straight to any index. Here's the intuition. For each candidate value G, count how many numbers are multiples of G. Any two of those numbers share G as a common divisor, so we know how many pairs have GCD divisible by G. Then we subtract off the bigger multiples to peel out pairs whose GCD is exactly G. First we tally. We find the largest number, so we know how big our arrays need to be, then bump a counter for each value. This frequency array is the whole input squeezed into counts, and it's what lets us stop thinking about individual pairs. For every G, we sweep its multiples, G, 2G, 3G, and add up how many numbers fall there. That count choose 2 is the number of pairs whose GCD is a multiple of G. Notice this sieve loop is the harmonic series, so it's fast, not quadratic. Pairs divisible by G include pairs whose real GCD is 2G, 3G, and so on. So we subtract those already computed exact counts. And what's left is pairs whose GCD is exactly G. We go from high to low, so the values we subtract are ready before we need them. Now imagine laying the sorted GCD list end to end. The prefix sum at value G tells us how many GCDs are G or smaller. So a query index just needs the first spot where the running total passes it. One binary search per query, and we're done. Quick challenge before I show you. 4 nums equals 2, 2. There's exactly one pair, and query 0 asks for its GCD. Pause the video and predict the answer. The GCD of 2 and 2 is 2. So exact at 2 is 1, and everything else is 0. The prefix sum crosses index 0 right at value 2, so we return 2. In short, one pair, one value, and our counting machine handles it without a special case. Honestly, in an interview, say this first. Compute all pair GCDs, sort, index, dead simple, and obviously correct. The plus is clarity. The killer negative is that 5 billion pairs blow up both time and memory, so it only survives on tiny inputs. Brute force is big O of n squared in time and space. Fine for tiny arrays, hopeless here. The sieve runs in about big O of m log m, where m is the largest value, plus a quick binary search per query. Pick brute force to explain, then ship the sieve for scale. Duplicates just add to frequent. So choose 2 naturally counts pairs of identical numbers. I shipped the off-by-1 version of this once. A Friday deploy, where my prefix search used the wrong bisect, and every query slid by 1. Never again. That's why I trust bisect right here. So we tallied the numbers, counted pairs per divisor, subtracted to get exact GCDs, and wrote prefix sums to instant answers. No billion item list anywhere. In short, when listing explodes, count instead. New daily drops tomorrow, same time. Keep shipping. See you tomorrow.